Hello. Is this thing on? Yes, apparently it is. My name is Ildefonso Camargo. I am with Command Prom Incorporated, and I will be talking about practical production quality PostgreSQL updates using logical replication with minimum downtime. Sorry about the long title. What makes really something production level, or what makes an approach production or qualifying for use in production? It is not so much the technology or the technical abilities of the people that you use, or the people that execute or use the technology. And that is important, certainly. But what does make the difference for production is the planning, the testing. In general, when you're planning, it is advisable to keep a work journal. Yes, our memories might be amazing, but what happens if you get sick and you have been testing the whole deployment and somebody else has to take over? Do they have to start over from the beginning? Come on, let's not do that to our teammate. Just keep a nice work journal where you keep notes, you keep thoughts, even mistakes. They are useful because your teammate might find those mistakes and then learn how to fix them that way. This second is important. Test the application against a full-size QA environment and take detailed notes. I have seen happen so many times with clients. They just go ahead and test their application like crazy using a database that is 10% the size of the production database. Then they go to production and surprise, it doesn't work. It is too slow. Some queries that used to be really fast on the older version no longer are. Reality is that PostgreSQL is a complex piece of software. It has a lot of, let's not call it guesswork, but it has a lot of interesting features in it because it doesn't do everything the same way on every version. Take, for instance, in version 12, the way CTEs behave changed. And now they are in line by default. They weren't before. This broke a lot of code from different clients. So you need to keep all of that in mind. And the only way to reveal these changes is to actually test on a database that is the same size as your production database, preferably the same data, because the characteristic of the data, the distribution of the data will change how the indexes are created, how they behave. And if you take an anonymized version of your production data, it might not behave the same. So in that case, yes, you would need to use the same team that managed production because of access restriction and all of that to do that final full-size testing. Planning. It's important to have a plan written so that you can follow the day of the changeover. I cannot forget, I was looking at a deployment, and literally these two persons were writing the plan, peer review it, and execute it in less than 30 seconds before executing the command. And lo and behold, they did make mistakes that made the maintenance window take longer than it should have. And it's better to always plan and have just a script that you follow top to bottom. Have the plan reviewed. No matter how good you are, you can make mistakes. Nobody is perfect. And I have many times the team has saved my butt because I sent the plan for review and they were like, hey, why are you not checking this? I was like, I don't know, sorry, let's do it. It's a good idea. And the plan review preferably needs to include executing the plan on a QA environment as well, meaning that the other person who is reviewing the plan now actually knows how to do the deployment, not just you. So if you get sick, if your internet fails or something, this second person can be invaluable for the team because now you can just tell the client, hey, that other person is the backup, he's going to take over the deployment, everything works as planned. No changes. Okay, let's move on because we are focusing on PostgreSQL upgrades here. So the preparatory steps. Check the release notes, evaluate potential issues. If you are jumping multiple versions, not just stop on the major version. Sometimes there are changes in the minor versions as well. A lot of people will already know this off the top of their head because they work every single day with the different PostgreSQL version. I have the example of Justin Graff, and a team member of us. He just knows all this stuff. Even he refers to the change logs of PostgreSQL. You need to do an initial application compatibility testing, and that is a small-scale test where you basically craft a basic database and be sure the application actually can connect to the new PostgreSQL version. Some older versions of libpq, for instance, would not be compatible with the new Scrum hatching algorithm for the passwords, and hence it might fail to authenticate. So you need to test that. Maybe you will need to upgrade some libraries on the application. So this is a small size test before going all the way into the planning of the logical replication and whatnot. QA testing, what I already mentioned. Basically, the database size needs to be about the same. Also the application load. I remember this other client. We spent 6 hours setting up a test, full-size test for them, and they put no load on the server. And I asked them, are you putting the production level load on the server? He was, yeah. And the server was doing nothing, so I found that really strange. So I insisted, and he insisted, and no, he didn't. Time passed, and when the actual switchover came, as it turns out, their application from time to time decided to truncate a whole table and recreate it with some 25 million rows, and that process kicked off right before the maintenance window. So back in the day, we were using Bucardo, and Bucardo had a bug, and when copying a whole table, it was particularly slow. And so I had to improvise in the moment and just copy over that table, synchronize the sequences and whatnot manually, and just finish the switch over. But this would have been averted if the client had done a complete production level test. They didn't. You can use pgBadger to aid into analyzing the logs and evaluating if some queries that used to be fast are now slower. Take detailed notes. I cannot stress this enough. And our memory can fail, and even if it doesn't, the notes are good to have. Okay, now the question is logical replication the right tool? Maybe it isn't. For one, logical replication upgrade implies an outage, roughly equivalent of restart in PostgreSQL, plus the time you need to advance the sequences and repoint the application. There are some ways, some intricate ways of achieving kind of no downtime upgrades, but more often than not, they do not work as intended. And take, for instance, the red-green, I believe is the name, upgrade on some cloud providers. And the recent experience we had with a client is that, yes, we started the red-green upgrade. The database was multiple terabytes in size. It took 6 hours or something for the cloud provider to decide to do the switch over. So what was the problem? The whole team, the application team, the database team, had to stay there staring at the window, waiting for RDS to actually do the switch over to test everything after the short maintenance window that, yes, was 1 or 2 minutes. The problem is the lack of predictability of it. As it is all automated, you don't have control over that. Maybe they will improve, and they will give you an option of prepare everything and then click a button to actually execute the switch over. They don't have that option yet. Can you dump and restore the database in your acceptable maintenance window? Come on, if you have a 1 gigabyte database, do you really need logical replication? You can probably dump and restore that using a pipe in a matter of a minute or 2. So sometimes it doesn't make sense, and you will just overcomplicate things for no gain. Maybe you can afford a maintenance window of 3 hours. Why not use it and simplify the process? It could be. But maybe you just want to reduce the downtime. Even though you could afford 3 hours, you would very much prefer to have 10 minutes. That's fine. Then you can use logical replication because you need it. Large objects are not replicated by a logical replication. If you use large objects, you will need a different approach. I have not encountered a client with large objects in like 12 years. So I do not know if there is people using large objects out there. Maybe they are. I have not seen them so far. If the database lacks primary keys on some of the tables or any other suitable index that can be used as a replication identity, we might have to fix it. There are different ways of fixing it, and the fix ultimately will depend on the application. Sometimes you can create a surrogate key, but that takes time. You need to create a new column, then you need to populate it with a default value out of a sequence or something. It's not simple. Fortunately, PostgreSQL in 16 and newer, I believe it started in 16, allows you to have different indexes on the subscriber side and on the publisher side. So sometimes you can create an index on the subscriber side to help locate the rows that are being updated or deleted on the primary server, and then you don't have to modify the original database, averting an additional potential downtime of modifying a table. But sometimes there is no way around. You have to do it. Sometimes you can create an index because you determine that a column that you had and you allowed null values, as it turns out, it never has null values. So maybe you can change that column to be a not null and then modify a unique index that used to have a nullable column to have no nullable columns, and now you can use it as a replica identity. Okay, I repeated that one, I apologize. You need a list of sequence of the database. This is another of the things that logical replication does not replicate automatically. The sequences, when you switch to the other server, will have the same value they had when you created the initial data copy. You need to advance the sequences after the fact or just before repointing the database. As I was mentioning, replica identity fault is an option for tables where we can create a subscriber-side index, or for tables that are very small. And honestly, 1,000 rows tables, you can do a sec scan real fast. You don't really need an index. So you can use replica identity fault. What level needs to be set to logical? And if you are on a cloud provider, this parameter might be abstracted as a different parameter. It will depend on the cloud provider. One interesting example is that AlloyDB from Google actually supports logical replication. It's funny because they deny it, but it works. These are some of the configuration parameters that we need to pay attention to when working with logical replication. I don't have the time to explain them all, but the gist of this is basically that you need to have sufficient replication slots to support what you're going to be doing with logical replication. Each subscription will create a replication slot. Each worker process that is copying a table is also to create a replication slot, but they can wait. And if you use up all the replication slots by using subscription-side data copy processes, and the following processes will just wait until they have a slot available and create their own and continue copying, doing the initial data copy. But you definitely need sufficient for assuming you are using the replication slot for your secondary server, you need for that, you need sufficient for the new logical consumer subscriber you are going to create. If you're going to create more than one subscription, sometimes you need that, then you need the replication slot for that. The parallel workers, we have to keep in mind the relationship of how PostgreSQL allocate parallel workers for the different operations. It is not normally a fatal error, but if you don't have sufficient parallel workers, you might be subutilizing your server. On the flip side, if you have too many, you might overwhelm the server. This is especially true, again, for cloud providers. Normally, when you rent a 4-core instance, it actually only has 2 CPUs. And some people say, hey, why if I go into 60, 70% of CPU use, it doesn't seem to get better as I add more workers? Well, the reality is that you only have 2 cores. You don't have 4. I'm not sure why they do this. One hypothesis is that they take advantage of hyperthreading, but hyperthreading and similar name for AMD, which I forgot, and it's mostly kind of a trick of running the same code with different parameters, so to speak, and at the same time. Oftentimes, you cannot do that. And so you end up, instead of 4 CPUs, with 2. So keep that in mind. Okay, the user for logical replication has to be able to read all of the publisher's tables, the select privilege. Otherwise, you cannot do initial data copy through logical replication. You could do it through different means, but it's a bit more complicated. And it has to also be able to initiate replication connection. So it needs with replication on the role that you're going to use. Also, the owner of the subscription needs to be able to set role to the table owner. And how logical replication works is that the process runs as the owner of the subscription. Then, when it goes to replicate and insert, update, or delete into a table, it sets role to the table owner. If it is the same, no problem, but if it is different, you might get this cryptic error, cannot set role to whatever user you have. So need to keep that in mind. And there is an option for making the subscriber run all the operations as the owner. It is not recommended because then it is possible for a table owner to inject code and run arbitrary code with the privileges of the subscriber by creating a trigger on their table. And if you trust all of your database users, then you can probably do that, but otherwise, that's the reason why it does set role, is so to avoid any users to jailbreak from the restricted table into other table by means of triggers. Okay, once we get to, once we determined that logical replication works for us and that we can meet all of these things, then we prepare and apply the configuration database changes. We determine what configuration changes I need to make on my origin database server. I need to be sure to plan properly because some of them, especially at world level, requires a restart. So if you know you're going to change multiple configuration parameters, just do them all at once and minimize the downtime, restart the server once. Again, if you need to modify an origin table, sometimes you need an exclusive lock. You might as well use the same maintenance window to not disrupt your clients multiple times. And I like to generate, well, not me precisely, this came from Justin again. Justin is our foremost expert in this area. He should be doing the presentation, but he was busy, so you got me. I'm sorry. Anyway, generate the commands to update replica identity on the tables as needed. As we were mentioning, if the table doesn't have a primary key, you need to either change it to use index or you need to change it to false. And if you don't set a replica identity and the table doesn't have a primary key, write operations on the origin table will be denied, and you could break your application that way. So this is part of the planning. You need to be sure all of the tables has the replica identity properly set before creating the subscription. Again, I insist this all the time. Test all changes on QA, everything that you have, and have the plan peer reviewed. The way I do it is normally I use the QA testing to write the plan. I just grab the plan template, I start writing. At the same time I am doing it on QA, I literally copy and paste the commands and the output and put them in the plan. Then the person who is going to execute can see what to expect, and that person is going to do it again on QA to learn. And finally, maybe me, maybe the other person, maybe another team member, because the plan is sufficiently detailed, can take over the production deployment. Okay, prepare the target system. A good start point is basically to use the same parameters, or approximately the same parameters that you have on the original server for the secondary. But you need to keep in mind the changes from the changelog. They are going to guide you into, for instance, determining that you need to modify some optimizer parameters for your goals. Ensure the pghba.conf files allow the application server and the origin servers to reconnect. Also, remember the replication entries. It's easy to forget them. This is because we are going to be modifying the target database. And after we do the failover, we're going to do a reverse logical replication for rollback. So we need to be prepared to allow the older server to connect. And ensure the pgBackRest backups are configured to point to a different location than the origin server. pgBackRest is sufficiently smart that it should not override WAL files. Under specific conditions, you could break it if, by chance, the target server has a higher WAL sequence than the origin server. Shouldn't be the case because it is new, but who knows? So better to point it to a different location than the origin server just to be safe. Then set up logical replication, create the publication. It's best to generate a SQL for this where we list each table individually instead of using for all tables. The reason being is if the replication breaks for any reason on a given table, we have the option of removing that table from the publication. If we use for all tables, we cannot do that. We have to destroy the publication and start over. So it gives us flexibility. The drawback is that if we create a new table on the origin server, we need to manually add it to the publisher and then refresh the subscription, but it's fine. Dump the globals and copy them to the target DB. This is basically the users and permissions and that kind of objects. And do bear in mind that if you're ready for an older version that use MD5 hash, you will want to upgrade to the Scrum SSH 256. The reason being that MD5 is basically broken at this point. You don't want to be using MD5 for any security related. Actually, if you try to get some security certification, they will fail you because you're using MD5 for password hashes. So it's important to do it. And yes, you can use MD5, it is possible. You just need to change the pghba.conf entry to use MD5 instead of the Scrum SSH256, but I recommend not to do it. Also, if you are on a cloud environment, I have not met the first one that let you dump the password hashes. They don't. So you need to use a parameter for pgdump to ignore the password hashes and then manually reset the passwords. At the end of the day, we need to do it anyway, so it's no big deal. Then we create the subscription on the target system. And an important detail is that the subscription does not use the .pgpass file. You need to specify the password in the connection string of the object. Now you confirm that the data is being replicated correctly and that there are no errors in the logs. There are a lot of cryptic errors from logical replication that you are like, what is going on here? You normally have to go to the logs to the beginning of the errors, and then you will find the actual problem, because after that, it just keeps repeating things like duplicate the key or whatever error that doesn't have anything to do with what you're doing, and you are all confused. You need to check the first error. And prepare the script or the SQL for the reverse logical replication that we're going to need. Finally, we prepare for the failover. Then we determine how much we would like to advance the sequences to avoid conflict. This is just to shave a few seconds of downtime. If we prefer, we can just do that during the outage. I prefer to do it that way because I feel a bit insecure about what if the client didn't tell me they had a big cron job that inserted 100,000 rows into a table and happens just after I generated the command. I prefer not to do it. Then we prepare SQL for disable logical replication. This is on the subscriber side. Let's disable the subscription. Prepare SQL for the reverse logical replication. It's important that we use with copy data false. Otherwise, it is going to start over and try to copy over the data, even though the database is completely populated. Prepare the configuration changes. The method for doing it will depend on the application, but it is always a good idea to back up the old configurations. Coordinate with other team members, application, send out notification, and schedule the failover. Then the failover process, we prepare the advancement of sequences, or we can do it after we stop the application. Then we stop the application, we disable the logical replication, set up the reverse logical replication for fallback. Notice that this happens while the application is stopped. And this is why we can get away with this. We know none of the databases is being updated now. If you receive an update at the improper time, you will have data discrepancies and you might have conflicts. So you need to be sure that no application, no scheduled job, nothing is writing to either of the database servers at this time. We drop the old subscription to clear the replication slope, apply the application changes, and start the application. The outage ends. Now we test the system, and if a rollback is necessary, we just follow the process, but to switch over to the old server. Because we are replicating the changes now the other way around, so we can just repeat the process, go back to the old version, and continue doing it. And then we will send out the notifications that the maintenance is complete. Well, this was just a briefing of what is going to be done. I'm going to try and do this in a practical manner now, and let's see how it goes. I'm guessing I'm cloning the screen because I cannot see clearly on this angle. Let me change that real quick here. For the sake of simplicity, I am using an in-cus system. This is what LXD became after the issue with Canonical. Okay, we will not be doing a QA testing. Or we can assume this is the QA testing, however you want to think about it. If we apply our checklist, we would say that this database should not be used in logical replication. I mean, it's 83 megabytes. We could just turn and restore it and be done with this real fast. But the demo then would be really boring. Let's see if the database lacks any primary keys. I know it doesn't use large objects. Well, I need to apologize with you. I was planning to have my notes hidden on my side, but you will see them, and they are... Anyway, you be the judge. I better don't qualify them myself. So basically, I had two queries. I had this initial query that is real simple, and it just shows you tables that doesn't have primary keys. And then my dear friend Justin, because he is who he is and a real SQL whiz, shared this nice query. And if I run it, okay, it doesn't complain, it doesn't give me anything because I don't have any table that doesn't have primary keys. Let me double check that. Okay. I'm just verifying something because I was expecting to see one. Okay, it's because the replica identity is already set to false. So alter table, test table, replica identity default. Try the most cost. Okay, there it is. The query that Justin created is actually pretty smart, and it takes into consideration the fact that the table has or not a proper replica identity. Because I used this same system for testing yesterday, I forgot to revert the replica identities. It was not showing the table. Now that I have reverted, this is a bug on this. Oh, come on. Anyway. After I reverted it using this, now the BigQuery shows the table, and it gives me a suggested command with the replica identity that it considers I should be able to use. Let's take a look at the other table. I had to add test table because the application didn't have any table with no primary key. So it is a good application. Every single table has a primary key, but it was too simple. We have this other one. So this one is also have replica identity set to false, so I'm going to revert it as well. Okay, there it is. Now I run the big query again, and now it shows different options. For test table, it suggests replica identity false, but for test table 2, it suggests I can use an index, this index here, or I can use replica identity full. I have those two options for test table 2. I have to make a choice, otherwise these tables are going to break after I start. So I'll set this to replica identity full for test table as I don't have other option. And for the other one, because of the time, I'm going to just right away use the index. You could set it to full, and then on the subscription side, you could set it to use the index, and it would still help with the sequential scans. Let's try to do it. Maybe we have the time to do it. Otherwise, you know that you had the other option of just using the index. Just look replica identity using index test table 2. Is the font size enough, or is it too small for everybody to read? It's okay? Okay. Okay. I'll follow the presentation sequence because that is the sequence that we were. Okay, we mentioned this. If the table didn't have, we have to fix it somehow. Okay, I need the list of sequences on the table. So let's see how can we get the list of sequences. I also have this query here. Actually, I believe I can just do a select star from PG sequences. Yes, and this is the only sequence we have. Just give me a second. I want to real quick open another document on this site, but I cannot show the whole Google Drive content. Come on. There it is. Okay, what I wanted to show you was this. This is basically a basic deployment plan template. You consider the risk analysis. You have pre-maintenance or pre-deployment steps. You have maintenance and deployment steps, and post-maintenance and post-deployment steps. So we are going to be filling it in as we go, and I'll go probably a bit too fast, but my intent is to give you this plan as a document. Go ahead. That is exactly what we're doing here. Yes, we are here. We are going from 13 to 17. So yeah, that is one of the main reasons why logical replication is cool. Yeah. Okay. Risk analysis and data loss monitoring, data loss for the duration of the outage. This is mitigated by informing clients about potential, including alerts, about potential missed alerts after and during the failover, also by monitoring and checking for alerts after the upgrade. Okay? The pre-maintenance, basically the step that we're going to take before the process. That is exactly what we are doing right now. So let's go back to our terminal. Okay, let's grab that pretty big query from our technical demo notes. Or a simpler query that will only list tables without a primary key. Of this list, you need to check for suitable unique indexes. Okay, this query is going to provide code to fix tables with no suitable replica identity. That is actually what it does. I just reverted the change to grab a sample output to provide on the plan. There it is. This is basically how I write plans when I am doing stuff for the clients. Let's move forward. I mentioned the list of sequence, that is PG sequence. There it is. Now I need to check for world level, so show all, and then I can check. Let me change the format again. In our case, world level is set to logical, otherwise we will have to plan for a restart of the database to fix that. I basically use show all, and then just search for the configuration parameter that I cared about. And the other parameters that I was mentioning, unfortunately, we don't have the time to go through all of them, but there are two here that are worth mentioning because they can create a very strange failure scenario. It manifests as follows. During the initial data copy, or when you have a long transaction that is not idle, it is a busy transaction, your subscriber just times out, disconnects, reconnects, times out, disconnects, reconnects, and you don't know why. The reason is because, in my opinion, it's a bug. Some people might argue it is not. But these times outs are just based on the worker and seeing some data being sent. On a streaming replication, it has keep alive messages that go back and forth, but apparently with logical replication, when the publisher is busy encoding the transaction and preparing it to send to the subscriber, it doesn't send the keep alive messages. And what happens is, if it takes longer than the timeout, the subscriber just goes away and say, oh, my primary just disappeared, I'm going to reconnect. Then it disconnects, the publisher side dies as well because it lost its client, and it starts again, and it starts encoding the transaction again, which again takes longer than a minute, which again times out and goes like that forever. So the only way of fixing this on the older version of Postgres is to set these times out sufficiently large to be sure you encode all of your transactions. This is mostly a corner case. I mean, how often do you have such a big transaction that takes over a minute just to encode? It's not common, but it's possible. It also can happen during the initial data sync. Yes, basically this is the same parameter, and that is why we do not disable it. Because we could disable it, but then you will have that kind of problem. If the network connection between a streaming secondary and the primary was to get broken for whatever reason, maybe a switch failover or something like that, then the secondary would never time out and would not reconnect to the primary unless you go and manually kill the. Another option is to have an attack or an attack. If you're using pgBackRest, for instance, you already have a web attack, and then you can configure the replica to restore the attack. And in that case, each side, because of the Camargo, the permanent attack has the web file. Then it goes and run pgBackRest and receive the web file from the front back. And in that case, the replica can protect the application as well. I'll try to move faster because I'm a bit slow. And I know someone else is going to need the room after me. So basically, we need to set this sufficiently large, and so that the transaction can be encoded. In my case, it's a tiny database. 60 seconds is plenty. But if you do see this behavior, that the subscriber is disconnected and reconnected and not doing anything else, you might need to increase this. Okay? The user for logical replication needs to be able to read and to initiate the connection, and the owner of the subscription needs to be able to set role. And for our case, we determined that the data was not particularly critical, and we could just run everything as the owner of the data. In this case, the Zabbix user. For this, we need to go into the Postgres 17 system. That is where the subscriber is going to be running. Okay, I don't yet have the user. Let's check on the primary. Okay, the Zabbix user has the replication role. Why it has it? Because we added it as part of the test we were doing. If we haven't done it, alter role Zabbix with replication, and that's it. That would basically add the Thankfully, these two parameters do not need a restart, so you can just change them as needed. Okay. Similarly here, because I am using the owner user for this, I don't need to care too much about it. Otherwise, how I fix it is by doing a grant Zabbix to and the user. And then I am basically granting the role to the other user, and now the user can set role into the correct role that I needed to work. Basically the table owner. Display table plus, and you can see the owner here. In this case, it's Zabbix for this whole database. Okay, the configuration changes that you need to make. As I mentioned, basically, I start with the same configuration, generally speaking, and I already did this because I knew I was going to take longer than expected explaining, because that's the way I am. But you just need to do that, translate the old configurations into the new, and that's a good starting point, and then start playing with it. taking into account the changelog of PostgreSQL. Do I need to modify an origin table? In my case, I might, but I won't this time. Basically, my test table 1 doesn't have a non-null index, doesn't have a primary key. The only way you can use it is through replica identity full, but I don't have the time, unfortunately, to go through this use case. Note that we basically have two choices. We add a primary key, maybe a surrogate key on the origin, or we work with an index on the target system. Okay, and this is the command to update the replica identity. This was already done on my plan with the big query that Justin gave us. This tiny query here. It's incredible, right? Anyway, and it already gave us the alter table commands that we're going to use. Test all changes on QA. Let's assume I have already done it, or that I am doing it now. Ensure the configuration parameters are equivalent and adequate for the target system size. If you're moving from especially if you're moving from a bigger server to a smaller one, this is important. But if you are moving to a really, really big system, you need to take into consideration the size and the overhead of the memory map. The virtual memory map can grow really large if you have like 300, 700 gigabytes of memory. In that case, you need to consider using huge tables, which needs to be allocated at boot time, or they will take a long time to allocate. And you probably will need to set up kernel parameter, and this is the system administrator and me coming out, because why not? Proxies VM min 3 kilobytes. These parameters sometimes need to be increased in systems that have large amounts of memory, and because of the virtual memory map size. In 99% of the cases, it works as is, but I have made it a point that if I have 512 gigabytes of RAM or more, I set this to 1 gigabyte. It prevents some weird problems that happen sometimes. Anyway, ensure the pgHBA.conf allows the server. So let's check that real quick. I am using Ubuntu, and that is why the file is located here. Otherwise, it would be on the data directory. And here it is. I am allowing host SSL. Why I enforce SSL? Because it is a good practice. Otherwise, a man-in-the-middle attack could potentially reject SSL initially, and then your client would be all too happy to retry unencrypted and then just allow the connection to be intercepted. So I prefer to enforce it. I am doing it the simple way, allowing all databases, all users from the whole network, but authenticated. Do not use trust authentication, and it is not authentication. It is just allow everything. Security is a multi-layer approach. You need to be sure that each of the levels make the life difficult for the attacker. They got into the application server. They shouldn't easily get into the database. And I need to specifically add the special replication database. That is why I added the note before. Remember the replication entry. It is this one. Because all, for some reason, doesn't seem to include it. But anyway. Now the pgBackRest, let's check the configuration. This is what I was mentioning. These are some sample pgBackRest configurations. We have the repo path here. And I am pointing it to a version. Now I go to the other server, to the origin server, the PG13. And the repo path is going to the PG13 directory. I did it on purpose. I like to separate it physically, even though pgBackRest has built-in separation by means of the stanza name. In this case, it has pgCBX stanza name, and the other is pgCBX 17. So it should be already separated. I prefer to do it that way. I just feel safer doing it that way. And one important thing about pgBackRest, especially when you're using cloud providers, is the archive get. You need to have process max set sufficiently high, and it can take a long time to bring over the whole files because each transfer takes a large time. And it's mostly because of the latency, not because of the throughput. You need to create a connection, it needs to authenticate, and then the data transfer starts. It's too slow, and it doesn't catch up. So you need to set it to a large value. I have found that 16 is like a sweet spot for things like S3 or cloud storage. And I am using SFTP in my case, which suffers from the frame overhead. SFTP is transfer needs to authenticate and takes a long time to do it. It is also a good idea to encrypt your backups. So, and yes, I have my super encryption key here, which is clearly very secure now that it's being recorded and all, but I promise I don't use it for production. Okay, now we are going to continue. I said here, create the publication, but honestly, I need to update my tables. I just came to realize to that, and I wouldn't have realized if I were not writing this command. So I need to alter tables, alter replication identities on tables that need it. I go back here to my output, and I choose the one that I like the best. For test table, I know I can use the index. Okay. For creating the publication, as I was mentioning, we wanted to use a script to generate the command because it doesn't allow you to just create publication, the name of the publication you want to give it, and then use a select, like a subquery to grab the tables and use it. It doesn't let you do that. So we need to use SQL code to generate the command and then run it manually. Entonces, so let's call it, let's say we call it demo publication. I'm going to basically put this into a SQL file because I do not see myself just pasting this into the command and then, no, it's just too much. This is in the origin server. Create publication SQL. And then let's try it. And there it is. It is the little command. But you see it has these plus signs and all of it here. You can just make it go away. I write it to another SQL file. And I can take a quick look at this. One interesting thing is that it doesn't include my test table. And I found this while I was testing yesterday. And this is the problem when you are working with code that is not your own. It's pretty long, and the reality is that it is filtering some of the tables out of it. And I believe it is because this table doesn't have any indexes on it, and it is ignoring it. Nonetheless, the query is useful, and for most databases, if I weren't adding these test tables for additional testing, it would have just worked directly for the Zabbix database. Well, now I just go ahead and run that monster query, which is nothing more than create publication, the name of the publication, for table, and then the list of tables. That's it. Oops, it's test table. There it is. Now I need to dump the globals. That's basically PGC dump all globals. There it is. And then I can pipe it directly to the other server. There it goes. It complains that my CMDRPL user already exists, and my Postgres user already exists. And this now should be broken. Why is it broken? Because the global from Postgres 13 and is using MD5, and I am enforcing the new hash. So I need to go to the other server, and I need to basically reset all those passwords. This one, I know I had it in the .pg path of the secondary server. The Postgres user, I knew I had it here. And yes, I also have it documented on my notes, but it is faster for me to access it this way right now. And the Zabbix one. I put it here. It is also in the SABICS configuration, in the application configuration. Okay, now my connection should be working again. We are fine. Create a subscription on the target system. There was one missing step here. As part of creating the subscription, we need to basically copy the schema to the target system. Basically do this pgDom schema only with create of the database SABICS, and we just pipe it straight to the other side. It should just work. And as a side effect, I actually copied the publication again. I'm sorry, in this, the API address is this one. There it is. I actually created the publication on the other side right away, and it was intended and not intended. Normally, people recommend not doing it because then you have both publications with the same name. I found it actually convenient because now I have the publication already created on my target database for my reverse logical replication at the end. Okay, now I need to create the subscription. Which is a command where you need to have the connection string right there. It's a command similar to this one. Okay, I call it demo subscription, host the connection to the primary server, the port, the user we are going to use, we mentioned is going to be the SABICS user, and the password, I need to set the correct password. It's right here. Okay, how did I call the other publication? Let's find it. Okay. Notice that publications are per database. That is why when I run it on the Postgres database, it was empty. I am on the Postgres 17 host. I am on the SABICS server, on the SABICS database. And it should be copying the data. Let's take a look at the logs. And here it is. It started, it finished, and so on and on. So basically, the initial data copy went on. And our database is here, 81 megabytes in size. And it is replicating now, or should be at least. Okay, I have this. Let's run it on the secondary server. It is there. Now let's do an update. Update test table 2 set args. And there it is. So we have replication going. What else is said here? I will confirm that data being replicated and there are no errors in the logs. We prepare the script for reverse logical replication. Due to time, I have to skip it, but it is literally the same. And what we are going to do is just create the subscription on the other side after we do the failover. Okay, prepare SQL for disable logical replication. Let's do that. That's literally the command to disable it. On PG17. Configuration for the reverse logical replication rollback. Okay? This is basically the same that we used. This is going to occur on PG13 after the failover. It points to the new primary. I'm going to use a different name, call it reverse. And important, as I was mentioning on the demo, with copy data equals false. Prepare application configuration changes. I already did that. It's basically, in the case of this application, it's literally just changing the IP. I start them here. And here it is. It is just pointing to the new database server. And in the case of this one, it has also a PHP web UI. I also updated it there. Okay, so those has been prepared. Coordinate with other team members. I am the only one, so I guess we are coordinated. And the notification, I self-notified myself I was going to do that, so we are fine. And finally, the failover, the entertaining part. Prepare SQL for advancing sequences. It is basically this little query here. I'm going to put it. And this is now maintenance. In this case, I know the sequence, and that the only sequence that Sabis has is a table for stashing okay, I am on the primary server. It's important. If I run it on the secondary, just look at this. The value is just 1,000 because the sequence, because it's new, it has been basically reset to 1. We don't want that. So that is why it's important to synchronize the sequences. Advance the sequences or do it during the odd age. We can do it now. I know that this application doesn't do a lot of work on this table. So we just run this on the Postgres 17. Stop the application. Here it is my command to stop the application. Put the new configurations in place. It tells me to confirm these permissions. I better do it. They look fine. And this is for starting the application. At this point, let me go back to my presentation. It says I need to disable the logical replication. So let's do that. I prepared the command here. Okay, that is done. Set up the reverse logical replication for rollback. Test the reverse logical replication. Okay, we did prepare this command, so why not? It says I need to do it on PG13, so let's do it. Okay, seems to have worked. It says here that it created the replication slot and all of it, and it shouldn't be copying over the data. If it was, I would see here in the PostgreSQL logs a bunch of errors complaining about duplicated and unique key violations and whatnot. It's fine. Drop the old subscription to clear replication slot. Thank you. I prefer to do this after the fact, but I noticed that it doesn't clear the replication slot, and honestly, it doesn't have any use. Once I start writing on the other side, the replication slot is going to hold on the new changes that are already occurring, and when you try to re-enable, it doesn't work. You really need to create a subscription again. So we need to drop the old subscription. And the old subscription will be on the 17th. Drop subscription, demo subs, in PG17. And yes, this is what I do when I am creating a plan. I literally go through the process and write it, and then potentially go again over it. Apply the application changes. I already did it, and start the application. Finally, the outage is over. Phew, this is taking a lot longer than planned. Okay. What else? It says that I need to test the system. Okay, let's confirm it is kind of alive. Oh yes, it came back to life. It had here our data gap, and then it is starting to get new data there. So we are back alive. How long did it took? Let me see, 12, 18, 12:22, so roughly 5 minutes, 4 minutes? Yeah, not bad for doing it here, talking and all of that, and without proper scripting. So can it be done in 2 minutes? Yes, it can be done in 2 minutes. And send out notification when the maintenance is complete. The maintenance is complete. Yeah. That's basically it. And we do have the 17 system, the 13 system replicating. I'm a system administrator, so I love the command line. Here it is, logical replication worker for subscription. So the logical replication is working on Postgres 13 and applying any changes we made. So the data is coming back to 13 in case we needed to roll back. We just need to execute the same process we did, but in the reverse order, to go back to the previous system. That's all, basically, and I cannot believe it I made it in time. Anyway, here are some references and resources. Of course, the PostgreSQL documentation, the 9 PostgreSQL Conf website, the pgBackRest documentation website, and the Zabbix documentation. That is the application I used. I have some special thanks. That's all. Any questions? Let's use this so that it is recorded.
Okay. You talked a little bit about when to use logical replication versus PG dump and restore. What kind of rule of thumb, like let's say you could have an outage window of like 12 hours or 48 hours, what kind of rule of thumb would you use if you, if you have like a 10 terabyte database or a 20 terabyte database, because it's... Right. So, like, if you were able to withstand an outage of 12 to 24 hours, would you just use PG dump and restore for something that's 10 to 20 terabytes, or?
Go ahead.
Yeah.
Well, the rule of thumb that we normally use is if it is going to take more than 15, 20 minutes, we use logical replication. I mean, even if the client can withstand 30 hours downtime, it normally comes with a cost. It is not zero. For some clients, it is just a complete no-no. We had a client who would lose $4,000 a minute. And we had a client who claimed they would lose $20 million per hour of outage. So can they afford to waste $20 million? Maybe they can, but do they want to? And it is a matter of balancing the cost, because preparing a logical replication failover can take 80 hours of work, 100 hours of work, including all the tests, all the adaptation. Normally, you need to do some application changes, some back and forth with the developers. Sometimes it is not worth it because the database is 20 gigs. So you can do it in 5 minutes, in 10 minutes. Instead of investing 100 hours, then you just need like 3 hours per work. So it is basically balancing the different costs and the variables. At the end of the day, it depends on the client. If the client, nonetheless, just wants to have their 2 minutes outage, we will use logical replication even if the database is small, unless we can dump and restore it in 1 minute. In that case, we will tell the client, sure, we can give you your 2 minutes outage, don't worry about it, and just do the dump and restore in 1 minute and call it a day. Because that way we are not in the business of billing the client just for billing the clients. Yeah, it doesn't make sense. We are there for helping people. Any other question?
Yeah, sure. Another question would be, what kind of schema, would you do any schema changes at all during the logical replication process? And I'm speaking specifically of going from changing like a serial identity or a serial to an identity, or, in the destination database.
Actually, yes. And logical replication is a great tool for doing schema changes where the data type is compatible. Take, for instance, you want to migrate from an integer to a big integer. You can use logical replication for that. You can even do it in the same database cluster. You just logically replicate to the other table, and then you swap the tables. So it is a great tool for these kind of things. And you can add filters to the rows so that you don't replicate everything. So it's an amazing tool. Basically, if the text representation of a data type can be cast into the target data type on the destination system, you can change the data type and change the schemas that way. Yes?
Another question I have is, when doing logical replication, do I need to be thinking about vacuuming or anything like that? If I have a 10 terabyte database where 2 terabytes is what do you call it? It's vacuumed. It's the data which needs to be vacuumed. Will logical replication take care of that?
Actually, yes, because the destination database is a master, it's a primary. So it is doing all the maintenance works in an automatic way as it would normally do. Of course, if you in your setting disable auto vacuum, not a good idea, but I have seen clients doing it, and you should enable it on the target, or you need to be running your manual vacuum processes normally as you do on your current master. But it just behaves as a normal master. Imagine logical replication is just a client applying the changes.
But on this, it's logically replicating the blocks.
No, it is not. It is just replaying the transaction. Yes, and not exactly, but you can think of it like that. So it is like taking an insert, it transforms it, but it's an insert essentially what runs on the target. So the stats gets updated. I couldn't show it off, but the stats get updated, sequentially scans get updated, and all of it.
Okay, I have another question, and this is related to schema changes. But if you're using partitioning, and let's say that, I mean, it sounds like if you can do schema changes, you could do partitioning changes as well. You partition the destination table however you want. If you need to change the time range or whatever, and then you just logically replicate to it?
I have not done it personally, but I understand you can use logical replication for that, because it is essentially replaying the SQL, and you just target the root of the partition set. And then when the new data is inserted, it just goes into the partition set. How it works is when you are updating or updating or deleting a row, it does a search on the destination and uses whatever indexes it has on the destination to locate the row to update. It might have a caveat somewhere because I saw an option in the documentation but it was on the publishing side, about publishing with root instead of leaves. So if you had partition on the origin and you want to partition in a different way on the destination, you might have to use the root as the publishing, probably as a separate publishing. But if the origin table is not partitioned at all, it should just work, going inserted into a partition data, a partition table. It should.
Well, I got another question would be, I haven't really done much work in setting up a test environment that is at the same scale of production. So, I see you had your Docker containers or whatnot there, and it's an 80 meg database, but do you have recommendations about setting up test environments that are on the scale of 1 to 10 to 20 terabytes?
Well, start with a small one because it costs money. Be sure the application starts, that you don't need to upgrade the libraries and whatnot. Once the application is running, you will need to put in the money into it and just pay for the rent of a cloud instance sufficiently large to do your actual test. This is especially true if you have high transaction level. If you know your load is very low, you might skip it. I still wouldn't recommend it, but you might just skip it and risk it. And because the test environment is expensive, and it can be $20,000 in the months you will be testing it. Additionally, you need to replay the load on the application because you have your nice full-size test environment. You need to put load on it, and that comes with it depends on the application kind of thing. Sometimes you can use, I believe it was called PG Replay, I forgot the tool, that basically parses the logs of a production system and then replaces the load on the secondary. It usually works. Sometimes it just breaks, but that kind of tool can be used just to load the database. But it's best to just load the whole thing, the application, if you can. Normally, these big corporations already have automatic testing systems that simulate web browsers and simulate clients and all of it. So you might leverage that.
Maybe a last dumb question, but you said you'd recommend logical replication for anything over 30 minutes. Like, I at what level would you say that you can't copy like a terabyte in 30 minutes? I mean, like what database size would you break that off as, if you could?
We had one client that had like 10 terabytes database, I believe. And because they were running a really old Postgres version, 9 something, logical replication was not really an option. PG logical might have worked, but I do not remember why it wasn't working. And they could take a 30 hours downtime. So they decided to use dump restored. And Bucardo was attempted, but several bugs byte in the scale and all of it, it just couldn't handle because of the transaction rate they had. It was too fast, and Bucardo is trigger-based, so it would just basically double the server load with Bucardo by duplicating the insertions into its own table and all of it, so it was not possible. And they could take the downtime, so they just did it. And they didn't use a plain PG dump. They actually used a custom script that copied the tables in parallel. So they were able to copy everything like in 12 hours. But they have a very gigantic server with all NVMe disks, physical machine, 700 gigs of RAM, like 128 cores, 25 gigabits network connection. So they had the resources to move in that much data in a timely manner.
Oh, maybe one last question for me. This demo was 13 to 17, but this is native logical replication, and that's supported by 12, is it?
Yes, it is supported by 12. I believe the support started at 10, if I remember correctly. And otherwise, you can use PG Logical. And that goes back all the way, I think, to 9.4, probably. Otherwise, you can use Bucardo, and it's basically abandoned now, but it can be made to work. You just need to hammer it a bit, and it starts functioning. Thank you. Yeah. Have a nice day.